Hello and welcome to our HOOPS workshop, Experiences in Developing 3D Marine Solutions. I'm Oliver Zimmermann, Senior Partner Development Manager in EMEA at Textsoft 3D, and I will be hosting this session today with my colleagues. I guess you all know this ship. I don't make a poll or ask the question around now here, waiting for answers, but imagine yourself in the position of Christopher Columbus at that time. You have a vision for something completely new, a vision to change the world. I believe Christopher Columbus was a visionary, but likely not an expert in shipbuilding. He did not need to, as he got partners supporting him, experienced craftsmen at that time, experts in shipbuilding. They were strategic in realizing his vision, which we today now all know about. Well, he did not discover a new passage to India, unfortunately for him, but a new continent, which was even more successful, especially for his customer, the Spanish crown. Now, meanwhile, the development of ships went further. More new types of and innovations of ships in its kind were developed over time. Today, the software solution providers allowing to support the whole building process of new ships in all phases, from the design to launch to outfitting with up-to-date 3D software solutions. Textsoft is a strategic technology partner, just like our partners who are presenting today are to their customers. Let's hear by some of them, DNV, NAPA, and Naval Architect, about their experiences and innovations they offer to builders of modern visionary ships. A brief overview for you for the agenda. There should be enough time for question and answers after the 10 minutes talk of our partners each. Please submit your questions either in the chat or you can ask directly after unmuting yourself in the Q&A session at the end. During the presentation, I would like to ask you to please stay muted and let me now pass on the presentation right to our first presenter, Derek Wan from Naval Architect. So Derek, I'll end my sharing and you can take it over from there.
Great, let me quickly share my screen. So can everyone see the presentation? Okay, perfect. So yeah, thank you very much for the introduction, Oliver. So my name is Derek Wan. I'm the co-founder of Naval Architect and also the head of business development. And in the next 10 minutes or so, I will give you a quick introduction on what we are building at Naval Architect and what Naval Architect is actually about. So let me start by giving you a quick overview of our background. Basically, Naval Architect started as a spin-off project from the University of Rostock in northern part of Germany. And my co-founder, Sebastian, he was doing his PhD there, specifically in ship design. And he came up with this idea initially in around 2019. And after successful first funding from the Exist Transfer of Research program in 2019, we started to work on the first prototype of Naval Architect before we actually founded the company 1.5 years later. So actually in this year, in February. And yeah, we then started to grow the team and received the second phase of the grant funding. And right now we have just launched our initial product for selected partners, and we are planning on a public version too. So, to achieve our vision, we have assembled a great team and that has the right experience and skills. So just a quick overview, Sebastian is responsible for the product and customers. I'm responsible for business development, marketing and finance, and also the strategy development. Gernot and Martin as software engineers, and Andreas, he is our coach and advisor with a very good network in the industry. And basically this is the core team that you can see here. And we also have additionally a couple more software engineers who supports us in the development process. And due to our recent funding, we are actually growing our team. So basically this is the core team that you can see here. And now let's start with the problem, or let's say the challenge that we want to address with Naval Architect, and we call it the information management challenge. And we all know the classical problem, right? So data is transferred back and forth between different departments, causing potential errors, duplication, and also difficult version control as well. And as you can see here, I split it up into three different sections. So you have multiple files and versions, so a high level of intransparency. All the files, or most of the files, are saved locally at different locations at different departments, and the whole process is not really synchronized. So it requires additional time, additional effort to really update those data manually, and also check if those data are still correct and up to date. So this is really just the basic idea of what we want to address in shipbuilding. And just a quote from some of the people or professionals we have talked to in the shipbuilding industry. So how can you actually quantify this problem? So an engineer of a leading shipyard, he told us he spends about 20% of his time basically on coordination, really just to find information he needs and to check if the data are still correct. And it sounds like a basic challenge, a basic problem that all of us know during our work time. So why is it really important in shipbuilding? Because the projects most of the time have high volumes, and you don't do that many of the projects, and most of the data or most of the details are really defined during the early stages of the design process. And so, if even small design changes and errors can have a significant impact later on in the shipbuilding process. So that's why it's important to really streamline the process to take care of these challenges as early as possible. And this is actually where we want to be in the future. So the current network, or the current process, you can say, is everyone talks with everybody, be it via email, via phone, or via Teams chats, or via Zoom. But we actually want to create a central ship model, so that stands in the center of all the communication, where the data and project status is clear all the time, and we can collaborate more efficiently, and hence also reduce the risk overall. And this is obviously a very high level concept, but probably just good for understanding of what we want to achieve with Naval Architect. And from the concept point of view, before we go into the live demo, our solution for the challenge that I have just mentioned is we basically are creating a cloud model where you have a centralized digital ship model where every stakeholder can work on. So it can be internal stakeholders from the shipyard's point of view, but it can also be used efficiently to collaborate with external stakeholders, for example, suppliers. We also have design offices and other contractors and subcontractors. So what is Naval Architect? Naval Architect is a cloud-native design platform that runs directly in the web browser. You don't have to install anything. You just need to register and then can basically start working. And it's there to connect the stakeholders in shipbuilding projects. And our vision really is to, in the future, develop a digital twin technology for ships that is used not only from early design, but also goes on further through construction and operations as well. So this is our vision. And the central ship model is maintained and easily accessible throughout the ship's life cycle, and should serve as the single source of truth for all stakeholders to collaboratively work on. So this is just the concept, and I'm just going to show you the live demo, and I've structured this into 3 areas. So basically, the first thing is modeling. How does it work with Naval Architect? The second thing is how does the information management work? How can you connect different properties and characteristics of a ship with the model? And the last thing is, okay, if you have all those features, how do you actually work efficiently together with other stakeholders? So we call this engineering change management. I can also say version control, actually. So those 3 areas. And by the way, so during the development process, and also now, we obviously used Hoops and Parasolid as the key SDKs during our development. So Hoops Communicator for web-based visualization, Hoops Exchange for data import and translation, but also Parasolid 3D geometric modeling kernel technology. So they also played a huge role in the development process. And you can basically now see, if I switch my screen, how the product actually looks like. So just a short intro. So the first thing is, as I mentioned, 2D, 3D modeling. So you can see my screen, right? Okay. So you can basically have different views, 3D views and 2D views. And this is just an empty project. So where do you want to start? You want to upload a ship surface. This is, or you can use different file formats, right? IGES and STEP and so on. And there you have the ship model, and you can also look at the midship section. And now let's start to model a bit. Let's add a deck. I just draw something just out of my head. Shouldn't be too realistic, but anyways. So this is just the bottom part, and I can basically just create another one. It's probably the ceiling in this example. And you can see that in the 3D model, everything is updated accordingly. So this is what we call fast modeling. You can model in 2D and at the same time create a 3D model. So you save a lot of time, and it's quite efficient and not so common in the current early design process, right? You basically, nowadays, you only model in 2D. So now you can define what's the ceiling, what's the floor, and then basically create a deck plan. So then let's also add some bulkheads. Let's just start from there. Okay. And keep in mind, this is a topological model. So yeah, if I draw this line here, and it basically connects between those two areas. And if I move one area, let's say the middle part, and this automatically recognizes that you will move the whole part. So this is a connected topological model, and you can see here in a 3D model it's also there. Obviously, you can have different rendering models. There's an X-ray, and let's also look at different cutting planes. You can see here right now nothing is inside. But if you go on with this and yeah, spend some more time, you can actually also add the GAP below it, and then be a bit faster, and then recreate the model basically, and then you can see that you can go a bit crazy with this, and then create a more complicated or more complex model. And now the question is, okay, how do you connect this with the properties and characteristics that I've mentioned? So right now we have added equipment. This is an engine. You can see on the right-hand side that this is connected with all the relevant properties. You can define for yourself what kind of properties you want to include. And on the left-hand side, you also have the structure. You can also be flexible in how you want to structure the whole properties and the informations you want to have. Obviously, you can load different geometries for the equipment as well, and for the components. And then you can just add this component to the actual view. All right, and for the last part, the change management. So here you have the basic marine, the structure here that you can also upload. And then you can define, so any changes that you made, that you are making with this model, it will be synchronized with all the other users, and it will be recognizable in the version control chart in the end. So you can also, and it saves different versions. So you can basically jump into another version to see what has changed there. And you also have a master version. You can create different branches, and you can merge those changes in the end. So you can see I just changed the planning status from revision to approved. And in this change model, it will show you directly in which areas you have made changes and how many changes there are. Obviously, this is just an example, so you cannot see a strong version control chart there, but in the end, if you have different users and different versions, you have a longer version control chart and also different branches, and you can jump in to see immediately who has changed what at what time. And this is very helpful for the coordination process and also for collaborating. And this is a standard process basically in software engineering, and we want to bring this to shipbuilding as well. So I guess my time is up now. So thank you all very much for listening and for seeing this presentation. Obviously, this was a very quick intro. So if you have any questions, just let me know. Thank you, everyone.
Well, thank you, Derek. Very good. Thanks for this interesting insight of this cloud-based collaboration solution for shipbuilding. We'll take the questions in the Q&A session at the end. And I would now like to ask to give us back the screen, stop your screen sharing. Yeah. And the next presenter will then be Lasse Helenius, who is actually a real naval architect and lead software developer at NAPA Design Solutions in Finland. So, Lasse, the floor is yours.
Okay, hello. I hope you can hear me and see my screen.
Yes, it's all good.
Okay, good. So my name is Lasse Helenius, and I'm working currently as a lead software developer at NAPA. And today I will give you a short presentation about NAPA as a company, the software solutions we are offering, and how do we utilize HOOPS technologies in our products. First, the name NAPA, it's an acronym from words Naval Architectural Package. And we offer solutions for ship operations and ship design. The company is more than 30 years old. We are a very global company with 190 employees in 10 different country offices. And we are very proud to say that 95% of ships built annually all around the world are built by NAPA customers. The software solutions we provide can be roughly divided into three main categories. In design, we offer an integrated 3D design platform for initial and basic design of a ship. And the target customers are mainly shipyards, engineering companies, class societies, and other authorities. In safety solutions, we offer decision support tools like loading computers, emergency computers, which are installed on board the ship for safe operations of ships. And in shipping, we offer tools for monitoring and optimizing the performance of the ships, such as voyage planning based on the weather and sea conditions. And today I will tell more about design-related products as there we are benefiting from HOOPS technologies at the moment. The software development for ship design started already over 40 years ago at the shipyard when NAPA as a company didn't even exist. And during the years, NAPA core functionality has evolved to cover 3D half-form design and hydrodynamics, hydrostatics and stability analysis under different loading and damage conditions, and also 3D structure design tools for initial and basic design stages, including 2D drawing generation, weight calculation, other kinds of numerical output, finite element meshing, and also direct interfaces to class rule softwares and detailed design systems. Originally, the application was a command-based, where almost everything was developed in-house, as at that time there were not many external toolkits available that we could have used. So we have had our own 3D geometry, which we still have. we used to have our own 3D graphics database, even macro language and so on. Then around 8 years ago, we started a big UI technology renewal to make the application more modern and easy to use, while still relying on the same existing core functionalities. And the application is named NAPA Designer, and the first official release was in 2015. And as you can see from the video, in NAPA Designer, 3D graphics plays a central role, and all kinds of interactions, they must be fast, accurate, reliable, and modern, also with very large ship models, including hundreds of thousands of structural details. And currently, Hoops Visualize fulfills these requirements for our graphics. And we have built two-way integration between our own geometry kernel and Hoops Visualize. So in the video, you can see while I'm creating some opening to the transverse bulkhead, and while I'm doing the modeling, it will automatically go into NAPA geometry kernel and stored into our database. And whenever something changes in our geometry database or geometry model, then those changes are immediately reflected to Hoops Visualize graphics as well. So there is this kind of two-way integration built in between the geometry kernel and the Visualize graphics. Then a few years later, when NAPA Designer was published, we started to get more and more requests to be able to share the design information more easily between different stakeholders and design departments, which are using different softwares. For example, outfitting designers, they need to know the boundary conditions from structure design, whereas the structure designer must take into account the piping routes and space reservation for different outfitting components. And at that time, we decided to take into use Hoops Exchange and Hoops Publish to solve this kind of information sharing problem between different systems. And a nice thing with the Hoops technologies is that Hoops Visualize and Hoops Exchange, they have built-in integration, which makes it relatively easy to import CAD components from different formats and visualize them on top of Hoops Visualize graphics. And then we have developed our own integration or conversion from NAPA geometry model into Hoops Exchange model, so that we are able to export our geometry into different CAD formats or publish them in 3D PDF or HTML formats by using Hoops Publish. Then recently, the demands to share the design information has increased even more. And with more than 1 year ago, we started to develop a web-based application for reviewing and sharing the NAPA model without any needs for installation on end user's device. And based on good experiences with Hoops Visualize on our desktop application, based on existing integration with Hoops Exchange we have developed, and based on some real evaluation process, we decided to use Hoops Communicator for 3D graphics and handling the streaming, the geometry and rendering and the interactions on the graphics. And currently, the NAPA 3D model geometry is converted into Hoops Streamcast format, which is a Hoops Communicator format. It is converted by using Exchange, our Exchange integration, and then converted to the Streamcast data by using Hoops Communicator converter. And then there are also some other tools for like calculating sections from the model or getting model attributes and so on, and this kind of information. Those are fetched directly from our core functionality by utilizing NAPA for calculating the sections and so on. And then those temporary geometry are drawn on top of the graphics by using Hoops Web Viewer API.
Hello, Lasse?
Yes.
Okay.
And last functionality in this web viewer, which is very important for information sharing purposes, is the commenting functionality. So the users can communicate together by adding some comments to the model, and the comments are then visible for all users using the web-based 3D application. And this application is relatively new, and the first official release is planned to happen in the end of this year. This was all I wanted to present about NAPA Hoops usage and NAPA products, all in all. Thank you.
Lasse, thanks a lot for that, for this overview of NAPA for design, viewing, and exchange. And it's really nice to see that you're using the full stack of Hoops SDK technology at NAPA there. Now let's switch the presenter and come to our last presenter, Jan Land, who's product manager at DNV, who will talk about the classification process of ship designs and how DNV helps to improve this process in 3D. Jan, the floor is yours.
Yes, thank you, Oliver. Right, I will use my 10 minutes today to first of all give a very brief introduction into what DNV does and also what CSAM does, which is a suite of software programs developed by DNV. We will then see how the newest addition to that family, CSAM Insight, is used to host a 3D approval process, as opposed to the previous or traditional 2D approval process. We'll see which technologies and trends are of use to us to make this change in our approval process happen. And finally, we look at a few examples, some screenshots basically of our application showing how we utilized TechSoft 3D products to achieve this, and a very brief outlook into what the future might hold. I think most of you come from a maritime background, so probably you all know what DNV is, but just in one sentence, if you are to build and operate a vessel or a fleet of vessels on the sea, you will need an independent third party such as DNV to basically verify that your ship is built and operated according to international rules and standards. So this procedure is what we call the approval process. CSAM, on the other hand, is a software brand which is also developed by DNV, which our approval engineers use to verify that a design is safe for operations, but which we also distribute externally to ship designers and shipyards and so forth. Today, I'm going to talk about CSAM Insight, which is the newest program in the CSAM suite of software tools, which we're using to facilitate a new way of doing the approval process, which traditionally has been on a 2D basis, as we see on the left-hand side on this slide, meaning that the shipyard or designer produces a 2D drawing, which is then sent to DNV or other classification societies for approval. And historically, this approach has made a lot of sense because in 2D is where ship designers started their work. But nowadays, of course, a ship designer will create a 3D model, as we've seen in the first two presentations. And then this extra step of creating 2D drawings just for the sake of approval is just unnecessary overhead, especially since on the classification or approval side, our engineers use those 2D drawings to again build 3D models for verification. So there's a new approach now to host this entire process on the 3D model itself. And what is helping us here is a new file format called 3D OCX, that is for Open Class Exchange format, which was developed in a joint industry project with DNV, but also with stakeholders from shipbuilding, shipyards, ship designers, and also very importantly, software companies, to make sure that this new format can find wide industry adoption. So the technologies and trends that helped us in facilitating this new 3D approval process is, first of all, the file format itself, which I just mentioned. So here I just posted a link if you want to do some further reading on who are the companies in the 3D OCX consortium to make sure that any changes proposed are transparent and adopted by all stakeholders. The second trend is that, of course, we see a move towards software as a service applications, and CSAM Insight is one of those software as a service applications, meaning it's a web-based tool for which you don't need any additional desktop installation whatsoever. Another area where we can see software as a service being a plus for us is on the sheer amount of computational power that is available in the cloud. Lastly, we are making heavy use of the Ctron cloud components for the 3D visualization on the web. Ctron, now being a member of the TechSoft 3D family, has given us quite good support, I would say. And what we learned, basically, what I learned at least, is that there is not one 3D component to fit all your use cases. So this is really about optimization, especially when we talk about software as a service application. So you need to know what is the use case you're trying to work on. Is it very, let's say, post-processing heavy on the end user side? That might require a different 3D technology than if, for example, you're mostly interested in showing large models or models with many parts, but maybe with limited post-processing capabilities on the end user side. So there's no one size fits all, but there are these cloud components that do a very strong job for those particular cases. And I encourage you, if you're interested in developing something in that direction, that you get in touch with the TechSoft 3D partners, because they can give you the right advice and make sure you're using the right technology to achieve your goal the fastest way. I want to share some examples just to show a few different angles of the challenges we met when trying to move a 3D approval process into a cloud-based tool. One, of course, is the size of the models we're working with. We're using CSAM Insight for different industry segments. For example, we use it for oil and gas installations, also for offshore wind turbines. But the requirements in terms of performance and model size that we get from our maritime stakeholders is, of course, quite a challenge. And we've been able to solve that quite well, I think. So it's actually really impressive to see that just on a regular web browser with the fairly standard internet connection, what you'll be able to achieve in terms of visualization and model size. Since we bring a lot of different stakeholders of the approval process on board of this application, it is of course important to show properties of these ship models that are relevant to the approval process. So here I just picked an example of where you can see which of these bulkheads or well, basically modules of the ship provide water tightness and which don't. So this is a feature of this OCX format that, of course, it's a 3D model, but it also is enriched with very approval-specific properties to make the job of the approval engineers more efficient, but also to facilitate a better communication between all the different stakeholders in this approval process. And speaking about the communication aspect, here we see that since all stakeholders, meaning the classification society, the ship designer, the shipyard, they all have access to the same single source of truth or the same model of the ship in question, they will be able to communicate through the application as well. So you can very quickly select a few parts, leave a comment, tag other people that have access to the same workspace, and really facilitate the whole communication process around the 3D model itself, rather than going through emails and other more cumbersome commenting systems. So this really ensures that you can have, efficient iteration and feedback loop. And we provide as well a version control system, which means that you can also create new iterations and new versions of this workspace, and it will flag you the changes as we go through various revisions, and you can sort of follow these comments as they get close towards the end of the project. This is another example of why it is important to pick the right 3D visualization components for the right problem. Here we're looking at a more detailed finite element view of a detail of a structure, in this case of a beam type structure. So you see the requirements are quite different from looking at a global ship model versus looking at very detailed aspects of maybe a strength assessment. So here again, the message is a lot of different views and options are possible on the web today if you pick the right components. So again, here a big thank you to Texsoft 3D that made that possible. Lastly, another challenge for us is of course to combine what approval engineers are used to from 2D drawings, at which they have become very efficient at finding the right measurements and finding the metrics that matter most to them, with the possibilities of having a 3D context. So we've spent quite some effort on reducing a 3D model to the main properties that are important to the engineer at the right time. Then I have used up my 10 minutes. The last slide is just a brief outlook of what we consider future plans for us. That might be that we could extend this approval process beyond the structural aspect. This is kind of our pilot to begin with. But of course, there are other disciplines involved in the approval process. And then quite generally, what we see as customer feedback everywhere, not only in the maritime, but in all industry segments, is that when they envision digital models of their assets, people have very different imagination about what that means. But one thing that they all think about is a 3D representation. So we think that 3D visualization in general on the web will play an important role going forward. So we'll have much more cooperation and jobs to do in the future. Thank you very much.
Well, thank you, Jan, for your interesting presentation. Really good. And I think we come far, meanwhile, after Christopher Columbus, Santa Maria design and building. And interesting to see the trends that or the experiences you all have looking at software as a service, cloud-based solution, digital twin, and web-based solutions. Now, I want to switch presenter again to my colleague, Stefania Tosa, who will now take over for the Q&A session.
Yes, thank you, Oliver. Just let me share quickly my screen. Okay. So that was great content from our partners. Thank you. 3 very compelling presentations, I would say, all very different. What they have in common, these 3 presentations, is that they are all using tools, SDKs from Texsoft 3D. So my name is Stefania. I work in Texsoft 3D as Partner Development Manager in EMEA. It is a pleasure, of course, for me to co-hosting this workshop. So just before proceeding to the Q&A session, I just want to touch on the toolkits that have been used in this presentation, starting from our CAD translation OOPS exchange, that supports more than 30 different file formats, proceeding to our 3D graphic engines for visualization, OOPS Visualize for desktop application, OOPS Communicator for web-based developments, and Citron desktop and cloud components, specifically used in CAE application to visualize and simulate in 3D. And cloud components, for example, is what DNV has been using in CSAM Insight software they presented today. Naval Architect instead bundled OOPS Exchange, OOPS Communicator with a geometric modeling kernel, Parasolid from Siemens. Finally, with OOPS Publish, it is possible to generate interactive 3D PDFs. And this is the case of NAPA using Publish included in our OOPS platform. So now it is your time. Please feel free to ask any questions. If you need any information, this is your chance. You may post your questions in the chat or unmute yourself as we keep this session open for you to interact with us or with our presenters.
So I will take this opportunity. So first of all, thank you. So it was really great to see these three applications in naval area. I have been part of one of such softwares, and I know how painful the job is. But looking at these softwares, it looks really impressive. I have one question for Lhasa, let's start with a comment. It looks very nice demo and the product overall. It looks very user friendly. Particularly, I was very impressed by the shadows based models that you had. Gives very realistic feel of the model for user. But I couldn't figure out whether you have a PLM system behind. How do you manage the different data that is interacted with the 3D model? How do you do that?
Do you mean the geometry behind the
yes, I
what
understood.
kind of data?
Yeah, so I think I understood that the NAPA platform provides interacting with the data, interacting with the model with some metadata.
Yes.
How do you use that? How do you save that over the life cycle of the ship? Is it a PLM system? Is it just your own database, or how do you do that?
Yes, it's our own database system and our own data management system, and also our own 3D geometry kernel. So we are not using any external parts or toolkits for managing the data or processing the data itself. So graphics rendering and for the export we are using Exchange, but otherwise the data stays in our own database and it is managed and processed by our own core functionality.
Know that. So thank you.
Thank you, Sumit, for taking the chance to directly ask this question.
I have this is Maria. I have a question for Derek. Very interesting presentation. Thank you. I find in this what I would call a coordination tool that you presented for obviously improving efficiency amongst teams. Can I ask who your target audience would be? Who would benefit from using your tool? Which type of companies?
Yeah, thank you very much, Maria, for the feedback and for the question. What you are referring to as the coordination tool, you probably mean the change management tree that we have in the end. Yes, so the target users are actually, so it can be a shipyard organization. This is our main customer, let's say, let's call it this way. But also external stakeholders such as design offices, engineering offices, and suppliers. Because during the design and planning process, the shipyards will obviously work with different stakeholders, including external ones. And in this process, it's highly efficient to have a version control system such as that. But also, if you only use it internally, it can be helpful for different departments. Let's say the calculation department, the procurement department, but also the design and construction departments. because they need to exchange data continuously. And yeah. So,
okay, thank you. And by the way, congratulations on your new release.
Thanks, Maria. We're very happy to start our first pilot project with a leading shipyard, and yeah, exciting times. Thanks.
I have an extension of the question, Maria. Thank you. I think it also invoked some thought process. This is for Jan, because DNV, what I understood from the product, it is being used for certifications. If I can simplify that, is it used only within DNV, or do you have some users which are outside DNV, like surveyors who are on shipyards, or the ship owners who wants to review what has been certified, rejected, approved? Do you have those kind of users as well for DNV?
Yeah, thanks for the question. So I would like to split this question in two, because one is this 3D OCX format that is underlying this whole 3D approval process. And that format is meant to be, as the name suggests, open class exchange, meaning that the more people and the more organizations that agree on this format, the better. So here collaboration is the goal between anyone who likes to use that type of format. For the application that I showed, See Some Insight, we use this to pilot this 3D approval process in DNV today, which means that it's not only our approval engineers that have access to it, but it's a shared workspace between all stakeholders. So the ship designer, the shipyard, they also have access to the same 3D workspace, just to make the communication and visualization more efficient and easy. And so there's, well, obviously there's a strict permission management who gets access to that workspace, but those that do have access, they can well, interact freely on it, and it can include different disciplines. We had actually some requests from the surveyors. The application works on portable devices such as a tablet, for example, as well, but it's not yet optimized for that. So we have a job to do to make it work well on, like, what if you're wearing gloves, you're in a double hull bottom of the ship, you know, maybe no connection whatsoever. So there's some job to be done, but that's the idea, at least. Yes.
Yeah. That's a classical indication of how do you make a classical or traditional CAD application to work for manufacturing industry or industry where the workers are required to keep their hands free, but at the same time capture the input in your application. So I can totally imagine, and it would be really interesting to see which way the thought process and the design goes for this application in future. Yeah. So yeah, please.
Absolutely. Yeah. No, thank you. We're in touch with our own surveyors to figure out how that can be achieved by possibly a simplified application of what you've seen before, and, you know, one that is to be used in a more robust way, let's say, in a difficult work environment. Thank you.
As a first thought, do you think that something like AR would be your target technology in future? Do you think that?
It could be for sure. We have some research projects that are trying to do exactly that, but that is not in production yet. So, but the thought, of course, is a good one. So let's see where this goes.
Yeah. Just a last comment that you might already be aware about, that the Hoops Visualize also comes with a AR sandbox. I don't know if you have tried, if you have any feedback on that. So I'm part of the product management team, so I'm more getting into these details. So I would be really happy to know afterwards if you have any specific feedback on that. So the AR sandbox that we have.
I see. Thank you. We're using Hoops for some of our desktop applications. We haven't used that Hoops component just yet. So yeah, I need to learn some more.
Yeah, maybe what having a look at it. So maybe if you have questions, we are also happy to help you in that.
Great. Thanks a lot.
Thank you, Jan.
Okay, thank you both. Very interesting. Anyone wants to ask additional question?
Yeah, I have a question for Mr. Derek.
Go ahead. Yep.
So first of all, I'm new to the industry, so bear with me, just a college student. So from what I saw, you're basically building a centralized network for information sharing, right? Like through a cloud platform. Is that correct?
Exactly, yeah, that's correct.
The problem with that, like the main problem I'm thinking with that is how will you compete with companies that are using blockchain technology, since that is anyway decentralized and faster and definitely more secure than a centralized network?
Yeah, thanks for the question. So I guess that's a very interesting one. So our thought is, so what is actually the benefit of having a blockchain technology used in shipbuilding? I guess that's something to be explored. But our thought is really the benefits of having a centralized digital ship model really is a step forward in compared to the current process of designing mostly using desktop or standalone solutions. So yeah, I'm not sure how really to let's say
Got it.
how
considering the system now, it would be better. But like if you
yeah.
think 2 to 3 years ahead, that might cause a problem, because decentralized systems are better right now compared to centralized, especially in security, which I think is a major concern considering a cloud platform, because there could be data loss, there could be data that could be hacked, and blockchain would provide transparency. So like how would you compare in the coming years? Because that would definitely be a better solution. Maybe think about that.
Yeah, no, I mean, I guess that's an interesting thought, and we have to see how we can really implement a blockchain technology in the future, and whether that might add additional value. But I guess that's a very interesting thought we can explore further. So yeah.
Okay, thank you. Yeah, that would be all for me.
I'm not an expert in that, but maybe I'm not sure about blockchain, how it is able to handle, the size of the models that are used in here.
If blockchains can handle much higher sizes than a small model, but it's basically it's a new technology, so yeah, a lot of people aren't really used to it. But like it was mentioned that some company was going to use it to like I think Naval Architect is using centralized network to share information between shipbuilders and everyone around them, right? I did hear like some company was going to use blockchain to like relay information between the consumers and the ports and all that. So that's what I was wondering, like if ports and all use blockchain technology, then maybe you should also shift to that instead of a centralized network.
Yeah.
But yeah, that's what I mainly wanted to know, like why a centralized network would be better than using a blockchain.
Well, it would be interesting to see if that's also not just in shipbuilding, but if you handle large CAD models, then it should also be in, like architectural, engineering, construction, BIM models. Are they already within blockchain technologies or digital factory solutions? Everyone handling a 3D digital twin model, basically. I also do not know, but interesting question, and thanks for that one.
Yeah, no problem.
All right.
I would have one more question for Derek. So thanks for the presentation at first. And I was wondering, to which extent are you planning to integrate calculation or designing tools into your software? For example, like line fairing or simple potential theory solvers for hull form design or something like that.
Yeah, thanks, Robin, for the question. So that's definitely something we are considering to include in the future. So right now we have created let's say a first version of a product with let's say the minimum viable features that we want to include, and that might be useful. But specifically for a hull design, we are also planning to work on this, as Sebastian has some specific knowledge in this area due to his PhD research. So this is definitely something you want to include in the future. And regarding other features such as calculations, for example, the benefit of our product is really to have a information model that you can, let's say, where you can pick out the specific data that you want. For example, you can ask the model to provide you what's the planning status overall for all the components that you are procuring from the outside. So is it already procured? Have you requested the price, etc.? And you can basically get a summary of all the data that you need. And you can also do something similar with calculation. So really, how many of the parts have, or the components that you have included have specific prices already, and what is the current estimated cost of the ship? And you can also specify this continuously when you have a more refined model. So basically, this is where we are starting, where you can use the intelligent model to for calculations. But besides that, in the future, we'll include more and more features to integrate more departments within the shipyard to use our model more efficiently.
Okay, thanks.
Thank you, Robin, for your questions. Thank you, Derek, for answering that. Anyone else wants to ask questions to our presenters or our Techsoft 3D staff today? I don't see any other questions. Also in the chat, we have already covered summit questions, so we're good with that one. And we're also close to a full hour of workshop, which is good. So, okay. So, well, thank you very much for your time and questions today. It was a pleasure to host this workshop. Thank you for the exhaustive presentation from our partners, Naval Architect, NAPA and DNV. At this point, should you have any further questions that we couldn't address today about our toolkits, our partner software, please feel free to reach out through our Techsoft 3D website. Actually, the link that you see on the screen will lead you to our Talk to an Expert form. Oliver and myself and all the partner development team will be happy to follow up. Thank you, everyone.
Thank you. Have a nice day, everyone. Thanks.
Well, thank you all for the participation this late morning. We hope that it was interesting to you. The link to the recording we will send out in the follow-up to you. Have a great day and rest of the week.
Have a great
Thank
day.
you.
Bye.
Thanks, everyone. Thank you.
Bye-bye.
Thank you. Bye.
Bye.